Hi, my name is Jose Mesa. I am an undergraduate student of the Civil Engineering Department at the University of Puerto Rico at Mayagüez. In summer 2012, I worked in the Summer Research Opportunity Program of the University of Michigan in the Lab Architecture and Marine Engineering Department. Our research title was the Seismic Sloshing Response of above ground oil storage tanks, and the research was conducted under the supervision of Professor Kevin Mack. I hope you enjoyed my presentation.
The research objective was to understand the seismic sloshing dynamics in cylindrical tanks, obtain knowledge of protective system base isolation and his application on oil storage tanks, and perform numerical simulations using open foam with the volume of fluid method. As we all know, oil storage tanks are an essential component of any country infrastructure. Above ground tanks are susceptible to earthquake loads. For this reason, we need to increase our knowledge on this kind of structure to avoid structural failure. We're going to evaluate protective system, in this case base isolators, and its effects in the structure seismic response. To be able to do so, numerical simulations with fixed base and base isolator will be performed. In addition, a grid refinement study was performed to select the optimum grid. As mentioned before, OpenFOAM, that is a finite volume computational fluid dynamics program, was used to perform the simulations. In addition, we applied the linear theory equation 1 to determine the natural sloshing modes of the structure and compare with simulation results. For the grid refinement study, 5 grids were developed. Figure 1 shows the coarse, medium, and fine grids and its respective results. All grids predict similar patterns, and the results of the fine grid and very fine grid tend to match. It was observed as the mesh refinement increases, more details can be obtained of the fluid-free surface. We performed the runs in a range of 0.5 to 2.5 readings per second for both cases. Figure 2 displays the results for the coarse, medium, and fine grid. For the fixed base case, the purple line in the figure represents the frozen liquid. As shown, 2 cases are in resonance, for the frequency of 0.71 and 1 readings per second. These results match with the linear theory estimates of the natural periods. In all simulations, 2 peak forces were found, at the excitation frequency and 1 at the lowest natural frequency. Figure 3 shows the ratio of the base isolator force and the fixed base force. A reduction in the fluid force due to the base isolator was achieved for a few frequencies. To simulate the base isolator, a code was developed to solve the equation of motion, equation 2. Dr. Kevin Mackey and Dominic Pirro, PhD student, assist in the process. Figure 4.8 displays a case where the fluid force increased to the base isolator. Figure point B displays the opposite behavior. The fluid force had a big reduction due to the base isolator. In all cases, a peak force shift due to the base isolator was observed. Here you can observe the animation of the numerical simulation for the fine grid. The amplitude used is 0.73 meters, that represents 5% of the tank radius, and a frequency of 3.56 readings per second. The fluid level for this case was 50% of the tank height. It is possible to observe a great resolution in the free water surface due to the great refinement. At the end of the summer, our conclusions were that with an increase in mesh resolution, more details of the free liquid surface can be obtained. Since the pressure and tank wall force time history match in the fine and very fine grid, we decided to perform the simulations on the fine grid since less computational time was required. Protective system base isolators improve the tank seismic response in some frequencies but not in others. I want to give special thanks to Dr. Kevin Mackey and his research team for their effort to make all this possible. Finally, I would like to extend my thanks to the University of Michigan for the opportunity of experience a high-quality research and learning from a well-prepared faculty.